The freedom of flight is only possible with careful attention to your aircraft. No matter where you're headed, get there safely with proper maintenance and regular inspections. Safety is paramount at Hartzell Aviation, where we build reliable products and power general aviation into the future. And we're growing, so let us introduce you to our family of companies. Hartzell Aviation's flagship is Hartzell Propeller, headquartered in Piqua, Ohio. Hartzell Propeller is the global leader in advanced aircraft propeller design and manufacturing technology for general aviation. Hartzell Service Center is where we provide aircraft propeller overhaul and repair. Hartzell Engine Tech is our leading OEM supplier and aerospace technology company. At Hartzell Aerospace Welding, you'll find an FAA Part 145 repair station and PMA holder for exhaust systems and engine mounts. Quality Aircraft Accessories, or QAA, is Hartzell's Part 145 Class 1 and Class 2 repair station with the in-house ability to overhaul most engine and airframe accessories. Today, we'll tap into expertise found across each of the Hartzell Aviation companies. Led by Hartzell Engine Tech's Director of Product and Technical Support, Alan Buffkin, we'll get maintenance and inspection guidance straight from the manufacturer.
From this pre-flight checklist of the SR22T, let's take a look at the Hartzell Aviation products and which it encompasses. The first would be the exhaust. In this particular instance of the exhaust, we're going to be looking for general condition, security, and clearance of the cowling. We'll physically grab the exhaust, check for security, run our fingers around the cowling to make sure we have clearance, but we also, in addition, want to look for any sooting excessively or fluids leaking from the exhaust, particularly oil. Moving on, we have this 4-blade short composite propeller. For this propeller itself, we want to check each blade in to make sure there's no nicks, cracks, or dings. We also want to check in and out play, as well as fore and aft play. Check the tip, make sure it returns to the center. We also want to look for any type of lightning strike damage. This damage will appear as brown spots or streaking or burn marks, particularly at the tip or trailing edge of the propeller. We want to do that for each blade, as well as check for debonding of any of the anti-ice and general clearance of the propeller from the hub in itself. We also want to check for the propeller spinner security of the hardware in general. Once we've checked all 4 blades, we're going to look at the alternator itself. We want to visually check that alternator, make sure it's secure, its condition is good, torque strips are in line. We also want to check our hardware, our ground, output, and field of the alternator. We want to make sure those leads are secure and tight and there's no chafing in the lines. This completes the walk-around pre-flight of the components, but let's take a deeper look. Let's decal the airplane and dive into that. And now that we have the aircraft decaled, let's take a closer look at Hartzell Aviation products from the point of a simple oil change to a 100-hour. But let's start at the top and work our way to the bottom. Here we have our magneto and harness assembly. The magnetos themselves you'll service per the manufacturer's recommendations. On this particular, you'll check leads, make sure all your leads are connected, nothing is loose. The harness itself is the same. You'll check for its general condition, its security. You'll work your way all the way back, making sure there's no nicks, chafes, anything that could be burned or even pinched. You want to check both it to the top of the cylinder and the bottom of the cylinder of the engine. Moving on from the magnetos, we have the turbo controller itself. As we move into the turbo system, we'll work our way down. This particular controller is firewall mounted. You want to check, make sure its security on the firewall is tight, nothing is loose. You want to check for safety wire connections are connected, all fittings are tight. You also want to look for any leaks or any obvious sign of damage to hoses. And so now here we're working our way down on that controller to the bottom side. On the bottom side, we want to look for the same thing that we did up top. We're looking for any obvious leaking. We're checking the security of those hoses along with the torque strip. As we work our way down from that controller, all the way down those lines, we want to inspect those lines for any type of chafing damage, any pinch damage, anything that we might see all the way to the wastegate assembly. We want to also check the wastegate assembly in itself. We want to know if it's free to flow. Also, the spring is in good shape, no corrosion, and not broken. As we make our way down from that wastegate to the turbo itself, we find ourselves at the exhaust. The turbo, which is connected into that exhaust, should also be free of corrosion. We should check our hardware where we're attaching in. We also want to check our clamps, our flange clamps that are here for bringing in our cold air intake side to that turbo, as well as the oil inlet and outlet. And as we work our way back into the exhaust, let's bring in our subject matter expert, Mr. Tom Hyde with Hartzell Aerospace Welding. Good to see you again, Tom. Can you tell me more about yourself and Hartzell Aerospace Welding?
Well, thank you, Alan. It's a pleasure being here. Prior to joining Hartzell Aviation, I was one of the original owners with Aerospace Welding for 27 years. I've also been an A&P mechanic for 40 years, and I recently earned my private pilot certificate.
Can you tell me more about this exhaust when it comes not just to oil changes, but also 100-hour in-depth inspection?
While doing an oil change, we just want to give a general look over the exhaust system, and what we're looking for is the general condition. What I mean by that is we're looking for cracks, we're looking at any heat distortion in the exhaust. We're making sure everything is secure and in place and not chafing and rubbing on each other. When it comes to exhaust leaks, which can come from a crack, can come from a loose clamp or joint, you may see some white, yellow, or reddish exhaust stainage in that area. If you see that, you want to take a close look, because that could be an indication of a crack, could be an indication of an excessive leak. So you want to take a real close look at those areas. We want to take a look at our exhaust gaskets where the flange meets the cylinder, make sure they're not leaking. And working our way down, we want to look at the heat shields. Many of the turbo systems have heat shields installed to keep the heat away from critical areas in the engine compartment, keeping in mind that one of the major concerns with exhaust is fire. And what I mean by that is if we have an excessive leak of this high heat, which can be as high as 1600 degrees F. We can start a fire within the engine compartment. We could burn some of the wiring harnesses, oil lines, fuel lines. So fire is always a concern in any aircraft. And that's why we want to keep a close eye on any excessive leaks or cracks in the exhaust system.
Understood.
We want to make sure those heat shields are intact, they're not loose and rattling around. We want to make sure they're not chafing into the exhaust pipes, that they're just solid. From there, we want to go back and just look at our cabin heater. On this aircraft, happens to be up against the firewall back here. Every single engine airplane derives its heat for the cockpit from the exhaust system. So we want to make sure that the cabin heat shroud is installed correctly and that it's not loose and rattling around. From there, we want to go back and look at our exhaust tailpipe, as we did in our pre-flight, make sure it's still solid, make sure it's not chafing on the firewall, make sure it's not eroded, and make sure everything's intact. And there we want to also take a look at all hardware. The V-band clamps here on the turbocharged systems are something that we will talk more in depth in our 100-hour inspection time, but you want to take a close look and just make sure the clamp's intact, it's not loose, the safety wire is there, and that nothing is rattled loose. From there, when we're going more into a 100-hour or an annual inspection, we want to look more in depth into the exhaust. And what I mean by that is, again, we want to look for cracks and bulges of heat distortion. But if we have the opportunity to have the exhaust system off the aircraft, we want to look at where the pipes, one pipe joins into another pipe. We have a male-female slip joint here, and it's really, really important to take a close look at those to make sure there's not excessive gas leakage there, and make sure that when we reinstall it and put it back together, that we lubricate that joint with a high-temp anti-seize. As I pointed out earlier, these exhaust systems get up to 1600 degrees F. So when you use an anti-seize on an exhaust system, it's very important that you have the correct range of temperature. It has to be at least 1600 degrees F or higher. If it isn't, it really won't serve its purpose and it'll burn out very quickly. So when reassembling an exhaust system, make sure you lube all slip joints whenever you do have the exhaust off. Also, when you reinstall an exhaust system, it's really important when torquing the exhaust nuts that you draw the entire exhaust system up evenly, not one cylinder at a time. By torquing one cylinder at a time, you create stress on the rest of the system as it goes together. So it's really important that we torque it up evenly. Also back here at the turbo is one of the hottest areas of the entire exhaust system. So really pay close attention to this during the 100-hour or during an annual, especially for heat distortion, bulging of the material, or any cracks. If you see anything like that, that's evidence that that component needs to be replaced. Working back to the cabin heater, this is a great opportunity to remove the cabin heat shroud and do a thorough inspection of that cabin heater. All single-engine airplanes get their cabin heat from the exhaust system. One of our second biggest concerns in safety with the exhaust is the CO2 that could be going into the cockpit from the exhaust system. So you want to make sure that that heater is intact, there's no cracks, and no heat distortion in there. Make sure the shroud hasn't been loose and chafing. Make sure all the hardware is there. Make sure when you reinstall it, that all of the scat hoses are attached firmly. Make sure the hardware and screws are attached tight so it isn't loose and rattling or chafing. From there, we want to go back to our tailpipe here. We want to make sure it's solid. We want to look for any cracks, again, at the weld joints, wherever it connects to the wastegate. We want to look for pitting or thinning towards the end of the tailpipe. And we want to check the clamp once again. On this installation, there's a V-band clamp on this tailpipe to the turbo. Now, this installation, this V-band clamp does not have an AD, but on a lot of the turbocharged aircraft out there, there have been many ADs on these V-band clamps. They are life limited to 500 hours and must be replaced at 500 hours per the AD. Now I can show you some of these V-band clamps and explain to you more in depth what are the problems with them and what to look for. A lot of these V-band clamps have ADs on them, which is a mandatory inspection. And the reason there's an AD on them, I'm not saying it applies necessarily to this aircraft, but there are many turbocharged airplanes out there in the exhaust system that have these style of V-band clamps. And the AD covers many of those models. The main reason the AD is there is because these clamps, as they're constructed, are spot welded together with small little spot welds. And those spot welds are failing. Some of the clamps also have rivets that help reinforce, and a lot of those clamps do not have the AD, but you should always look at and read the AD for which models and which part numbers it applies to. As you can see, this is an old clamp. This is the segments that are spot welded into the clamp when it's constructed, and those spot welds are failing and these pieces fall out, and then the exhaust gas is allowed to come through the joint. As I explained earlier, fire is one of our big concerns with exhaust systems. Whenever these clamps fail, it opens up a crack or an area in the exhaust system in which the hot exhaust gas can escape and potentially cause a fire or burn one of the wiring harnesses. So that is why the AD is out there, and it is on almost every turbocharged exhaust system has several of these clamps throughout the exhaust system.
And now we've moved to the right side of the aircraft to give us our best inspection view of this particular engine mount. Tom, tell me more about this engine mount.
Alan, there's 4 things we're mainly going to be looking at on the engine mounts, and this applies to pretty much any aircraft model. We're going to be looking for cracks, chafe marks, bent tubes, and paint condition. And during the oil change, you can just do a general look over of the engine mount for those things. We want to look wherever there's a weld joint, where 2 tubes are welded together, or where a gusset may be welded between 2 tubes. Also our engine pads. These isolators are here to dampen the vibration. However, they are a very highly loaded area, and this engine pad here, as you can see, has a crack in it. Now this was an isolator pad inside of another engine mount welded into it, but even with the isolators here, it's still cracked. So pay particular attention to the isolator area, looking at the metal structure for any kind of bends or cracks. You want to go through the whole engine mount as best you can and look for any kind of cracks. Next, you want to look for chafe marks. Here you can see there's an engine, a tube, which has a chafe mark in it. Now, you look at this engine mount structure and you think that it may be very heavy and robust, but these tubes and most of these engine mounts are only 49 thousandths thick on the wall thickness. So all it takes is a small chafe in the area or a pit in one of these tubes, and it's caused to replace or repair the engine mount. AC 4313 will give you guidance on what is allowed for a chafe mark in an engine mount, and it's only 10% of the wall thickness. So like I said, if it's 49 thousandths wall thickness, only a 5 thousandths deep chafe mark or pit, and the engine mount has to be removed and repaired. Now, what causes some of those chafe marks? Well, we've got a whole variety of things that run around this main frame in this engine compartment. We've got wire bundles, we've got fuel lines, gas lines, even the scat hose routing rubbing up against the engine mount can chafe these engine mount tubes and cause a deep enough chafe to where the engine mount has to be replaced. Some of the more common things are the ADEL clamps. Now, this is a rubber aircraft clamp that's used on wire bundles and many things that are attached to the engine mount, but this rubber over time becomes brittle, it becomes worn through vibration and movement, and this rubber sleeve can become wore out, allowing the metal band to touch the tube of the engine mount and chafe into the metal. Okay, so always look at these ADEL clamps very closely. The rubber, never ever use a zip tie. Many mechanics over years, whether it's a certified airplane or an experimental, use zip ties to tie the wire bundles to the engine mount tubes. Those will vibrate and move and chafe, and they will chafe into the tubes, such as the example that I showed you. So never ever use zip ties on your engine mount to attach other things to the engine mount. Another thing you have is heat shields. There's a heat shield attached here on the engine mount tube. These heat shields are installed to keep the hot exhaust gas from burning the paint off of the engine mount. We want to check those and make sure they're not loose. Through time, they can vibrate and become loose. We want to make sure, again, those are installed with hose clamps. You want to make sure the rubber or insulation material they used on the inside of that hose clamp is still there and intact. And if it isn't, the clamp that is there will again rub into the engine mount tube, causing a chafe. So inspect them very closely. Another thing we want to look for, of course, is bent tubes. If we have a hard landing at times, wheelbarrowing on a nose landing or something of that nature, got a student pilot that lands hard, many of the single engine airplanes, the nose gear is attached or becomes a part of the engine mount frame. So it takes a lot of abuse when through a hard landing. You want to check all the tubes over and make sure none of them are bent. And the fourth thing you want to look at is the paint. So just look the paint over, make sure the paint is intact. It can get rubbed off through the chafing. It can also get burnt off through the hot exhaust gas, as I explained. Many of these exhaust stacks run very close to the engine mount frame, and they can, over time, burn or blister the paint. It's really, really important that you replace the paint as necessary when you find these areas. The engine mount is made out of 4130 chromoly steel, which is just a aircraft grade of mild steel. And if the paint isn't on there, corrosion will set in, and you can get pitting in the engine mount tubes as severe as actually getting holes right through the tube. A rough area like this on the surface of the tube is a sign of corrosion. These are pits into the tube itself, the base material, and if any one of these pit areas is 5 thousandths deep or more, again, per AC 4313, it's cause to remove the engine mount from the engine. So always take a look at your paint, make sure that paint's intact, make sure it's not blistered or worn in any way, and if so, make sure you touch it back up. This doesn't just apply to turbocharged airplanes, it's normally aspirated airplanes as well, and it doesn't just apply to salt air. This can be in any environment that can cause the paint to come off and therefore collect moisture and corrode. Getting further into it in your 100 hour, you want to take a close look at your vibration isolators. Make sure they're not dry and cracked over time. Check the torque on the hardware that attaches the isolator. Also check your bolts that attach the engine mount to the firewall. Look at your firewall in that area. Again, if you have a hard landing, inspect the firewall and make sure the firewall is not buckled where the engine mount attaches. Another area we want to clearly inspect is the bolts where the engine nose gear frame attaches to the engine mount. There's some cotter keys and the castellated nuts there. You'll have to remove them, check the torque on those bolts, and reinstall the cotter keys. While you're down there, make sure you look the paint over, make sure you look for cracks and any wear in those areas as well. Alan, that about covers all the general inspection of the engine mount, but one thing I'd like to point out is that we really encourage pilots to remove the engine mount from the airplane once they have the engine off the aircraft for engine overhaul or any other reason. The engine mount holds the entire engine on the aircraft, and it's the only convenient time to remove the engine mount is once the engine is already off for some other reason. Remove it, send it into a certified repair station such as Hartzell Aerospace Welding to have it stripped, inspected, NDT'd, fully repainted, and recertified.
Well, Tom, that's a lot of good information. I appreciate you stopping by and informing us and telling us all about your particular job and work. Now that we've covered most of the engine components from top to bottom, we're going to talk about the aircraft's electrical system. Of course, the electrical system of the aircraft, but this particular engine is a direct drive alternator, but there's also a PM2407 starter. On the PM2407 starter, it is buried pretty deep in the engine, but the three main things you want to check on this particular starter are, of course, the electrical input, stud for the starter, check it for torque, make sure that the line isn't chafed, and the cap cover is on protecting the stud. Also, you want to check the engine mounts. There are two bolts which hold this starter to the engine. You want to check them for general security and also make sure there's no cracking or anything loose or chafing in that area. Moving on from the starter, we'll now move forward to the alternator system. On the Cirrus SR22T, there are two alternators. Both are ES series, however, one is direct drive, one is pulley driven. Both alternators themselves are located on the front of the engine, of course the direct drive being here, and are belt driven being under here. Applicable to both alternators are the alternator wiring. Very important to check the main output wire, the field terminal wires, as well as our grounding. We want to make sure that all of it is secure, none of it is chafed, none of the leads are cracked, and it's very important on the output to make sure that we are torqued correctly. A loose output can arc and burn through studs. We also want to check the general condition of the alternator for any corrosion and its security to the engine mounting bolts, which are usually torque stripped. As for the belt-driven alternator itself, we want to do the same electrical connection checks, but we do want to check our bracketing for condition, possibly cracks, and we also want to check belt tension and condition of the pulley. For both alternators, we recommend that you follow the manufacturer's recommendations for ICA, but in addition on the direct drive, the ICA for the 500 special inspections for the coupling. These can be found in the manufacturer's manual. Now we've talked about the inspection of the electrical system, let's move on to our four-blade composite propeller. And here to tell us more about our four-blade composite propeller system is our propeller subject matter expert, Jared Woody. Jared, good to see you again. Tell us more about yourself.
Sure. I have approximately 12 years of aviation experience where I've worked in GA, military, and commercial. As a mechanic, I'm a certified A&P mechanic as well as a licensed private pilot.
Can you tell us more about our four-blade propeller from your perspective?
During the inspection of the blade, we'll look at the camber, the face, the trail edge, and the lead edge of the propeller, where you will possibly note any gouges, nicks, or damage that may have occurred, either to the paint or through the composite. At this time, it's vital that you assess that damage, and it may be necessary to actually take some of the layers of paint off to get an accurate account to the depth and size of the damage that's underneath these blades. The blades themselves may have a sandblasted appearance, which is normal and during any pre-flight can be deferred to a scheduled maintenance. However, during scheduled maintenance, if the sandblasted appearance or the paint that's missing on these blades exceeds anywhere from 5 square inches or approximately 13 square centimeters, it is advised at that time to go ahead and correct the condition by adding paint. Additionally, as you mentioned, lightning strikes may occur near the tip and move inboard towards the actual hub itself. During that time, temporary operation of the propeller is allowed as long as no other evidence of damage from the lightning strike inspection per the applicable owner's manual is noted. Additionally, we want to look at the anti-ice protection system that we have installed on your propeller. Here we have anti-ice boots and the feed tubes, or the alcohol tubes that run from the slinger ring on the aft of the bulkhead. What we're looking for on here is any premature raised areas on the boot itself, any heavy abrasion, cracks, or peeling or debonding of that material. The boot is type dependent for how much debond can actually occur on the propeller blade. At worst case or max, approximately 3 square inches or approximately 8 centimeters squared can be missing or debonding. But again, we don't want any premature failures of that de-ice boot on the propeller blade. In addition to the blade inspection for damage, we also want to note any oil or grease leak that may have occurred on the face or camber of the blade. Obviously, it's going to be much easier to see that with the spinner assembly off during a scheduled maintenance versus a pre-flight check. Oil has a photoluminescent element to it, which under a black light can show you the difference between grease and oil. If oil is noted, the oil will most likely be due to an O-ring seal seated at the blade, the hub parting line, or lubrication fitting on the side of the cylinder.
Jareth, on the 4-blade composite and the 3-blade composite, can you tell me more of what I'm looking for the blade axial play? How much play am I looking at? Can you explain more of that to me?
So the radial play is essentially a preload on the actual propeller blade. That occurs during startup and shutdown of this propeller. We would hate to have somewhat of a floppy blade inside the hub in here. The vibrations would cause a lot of damage to this. So what we ask for is just a inspection of both in, out, fore and aft. As long as it returns back to its normal position, we know that the blade is properly preloaded and that no internal wear has occurred inside this system which encompasses this blade into the hub.
Jareth, can you also tell me more about the hub specifically and the spinner? What am I looking at in these particular areas that I should be aware of?
So the front of the cylinder is actually placarded with a sticker, which will show what the propeller assembly has been lubricated with. In this instance, it's Nyco GN 3058. It cannot be mixed with any aeroshell product. The reaction between the two grease, as this is a synthetic with a mineral-based grease, actually causes a reaction within the propeller, which may prematurely wear out the lubrication properties of the grease that's used inside the propeller assembly. Additionally, during this time, you can see in the bulkhead, the doublers may show a tendency to crack if an imbalanced propeller is installed. One additional thing to note during the 100-hour inspection is the coin tap. Specifically, since we are dealing with a composite blade, it is a requirement that every 1,200 hours, not to exceed 1,200 hours, that the blade surfaces that are free of a boot are actually coin tap, and that the nickel erosion shield is also coin tap, not to exceed 600 hours.
Well, Jareth, I really appreciate your time and your expertise. I hope you enjoyed our video today on our Cirrus SR22T. I would also like to thank our subject matter experts that helped us produce this video today. At Hartzell Aviation, we are dedicated to provide aviation products and services that deliver uncompromising quality, performance, and support. For more information or to contact us directly, please visit us at hartzellaviation.com.